Hey guys, welcome back to Lane the Project Guy. This week we're working on the brake shoes for our Northern 484 locomotive. This is what it should look like. Here's one I have finished and have laying up there so you can see what we're doing. I laid them out on some paper just to get an idea of how this was going to go down. And I got an 8-inch diameter piece of steel that I'm starting out with. This video is going to be about making the blank that the shoes are going to come from. So I started off by facing this chunk of steel. It's about a 30-pound piece of metal, and I've never used anything this heavy in my lathe. This is the first time working with something like this, and I had a lot to learn. First of all, the lathe was just not up to the task. It just tripped off, and that's from overheating of the electric motor. This is the old 1 horsepower motor, which is not original to the lathe. So the first thing I had to do was upgrade to a 2 horsepower motor. Now I'm back to actually working on the shoes, and my plans are in actual size, so I can take some dimensions off the plans that aren't marked. And I want to make me a little template so I can mark out my radiuses on my blank and see where my cuts need to be. So I'll take my little scrap aluminum jig. You can see my 3 holes I've drilled using the DRO on the mill. I've got my scribe, and all I'm doing here is just etching some lines so that I can see where I'm going to machine to. And I thought this was a pretty clever way to accomplish this. And it made it precise, a lot better than trying to lay it out with a compass. Once I got that taken care of, now I want to start trying to carve this blank out. I start off with a parting blade, and the parting blade is very precise and worked well, but it could only go so deep, and then it started rubbing, and I started getting a lot of chatter. So I went over to my eccentric engineering diamond tool and started removing some material with it. And this steel that I'm using is, I bought it off eBay, and it's supposed to be 4035. And that's, when I looked it up, that's pretty machinable. But this steel just fought me all the way. It shattered bad, which you wouldn't think would happen with this big of a piece. And the surface finish wasn't good. It was just a tough piece of steel to machine. And you'll see it throughout the video. You can see the surface finish there is terrible. So I'm kind of trying to come up with a different plan. And I decided I would go with the boring bar. So I'm going to drill out as deep and as I need, and with the largest drill bit I have, which is 1/2 inch. So this is starting off at something intermediate on my way up to a 1/2 inch. And that's the lathe tripping off again. So this video was actually probably shot before I changed out the lathe motor. A little bit out of sequence. Here we go. All right. Start drilling, getting some really good chips. It's drilling nicely. And you kind of see my marking fluid on the circumference of the piece. That's about how deep I need to go. These brake shoes are 5/16 of an inch thick. So I just need that plus the parting blade and a little extra so I can face off my finished blank. Just pecking at it, making sure my drill bit doesn't get too hot, so it'll stay sharp. And then once I get deep enough in with this bit, I'll I stepped up to a 1/2 inch. Probably could have just pushed this on through, but I was really being protective of my drill bit. And there's my 1/2 inch going in. This is the largest bit I've got. As you can see, I'm cutting out some of the footage so that you don't have to spend the afternoon watching some processes that you know well. But stick with me on this, and you'll see it's a pretty interesting day of trying to make this slug that I needed as the raw material for my brake shoes. So now I've gone to the boring bar, and this boring bar worked really nice. This is a carbide boring bar. It's the brazed carbide tip. But this steel was so tough that even with this carbide, I had to go resharpen it on the bench grinder several times. It actually would chip off the tip. And I'd just lose my tip after a few minutes. So I think I reground this thing like 3 times till I got to this point right here. So now I'm sneaking up on that line that I drew with my template earlier. And that'll be the circumference of the brake shoe so it's a 5-inch hole that I bored out of there, and my train wheels are 5-inch. So that's where I come up with that. You can see that's dead on 5 inches. So now we've got to bring down the outer circumference to just a guesstimate. I wanted to get rid of as much metal as possible on the lathe and just increase the speed of the video to, I think this is 3 times normal speed to kind of blaze on through this process. Some oil on that diamond tool cutter. This diamond tool cutter, I had like an 1.5 inch piece of high-speed steel in there that was my tool, and I had to keep regrinding the tip on that. So I've got about a 1/2 inch of it left today as a result of that. This steel was just tough, tough. I'm kind of measuring how far I've gone into the plug to see if I for sure have enough before I part off. I don't want to part this off and then wind up with not enough metal to actually make the shoes. But it was fun seeing my lathe spin this old big piece of steel. And I put a little chamfer on there. You don't want much on this particular part, just kind of ease the edge a little bit. And the file was the best way to do that. So that's looking pretty now. Finish is good. And you can kind of see what I'm shooting for here. This is a pattern that I made on the copying machine from the plans. Now I'm parting it off, and this took a couple of hours. I don't have a horizontal bandsaw that'll cut through this 8-inch piece. My horizontal bandsaw is limited to 7.5 inches, but I got it parted off, so that went nice and smooth. It just took a little time. And now I wanted to face off this backside where the parting occurred, and I just could not get this to work. I reground my tool several times. It just kept knocking the tip off the tool. So I don't know if this steel is actually that hard or if I was work hardening it. So I took it over to the Bridgeport, clamped it down to the rotary table, and this worked fine. I got a nice finish doing it this way. So this is how I faced it off and brought it to the proper thickness, 5/16 of an inch. And I had some little gauge blocks and my calipers. Try to, so that was 0.328. I wanted 0.312. And maybe this is where I'm pulling my gauge blocks. Yeah, that's a little stack of blocks. And so I can see that that looks just right for me. And now that we got a depth set, we can go at it. Just double and triple checking. And some anchor lube I put on there, and that works really good to lubricate the bit. Keep this tool nice and cool. And as you can see, this video is not in real time. It's sped up. I think this is 2 times normal speed. But I can just take it right down to the final dimension in one pass. Now that I've got the dimensions set up properly in the mill. And it's worked beautifully. This is a 6 flute end mill, and it put a nice finish on there. I've got the original Bridgeport traversing motor on my x-axis, and it works good. I had to rebuild that, but so I put the plate back in the lathe. You can see I reversed my jaws so I can hold it from the inside. And what I'm wanting to do is put a little decorative groove. You can see there's a groove kind of showing. Before I started the video, I made a turn or two on the lathe, and the groove wasn't symmetrical. So I'm trying to get the plate trued up so that the tool will cut in there symmetrically. And I've got a little carbide tip tool. The high-speed steel just wouldn't do anything with it. And I put my little decorative groove in there. It's just for looks. It's supposed to look like the brake lining. And that kind of finishes up the blank. I went over to my surface plate just to see, after probably a day and a half of work, if this blank was close to being symmetrical. And it lays flat. In fact, it lays so flat that it kind of sucked down to the surface plate. It was hard to spin it. Had a vacuum under it. And as I spun it, I got about probably a 4/1000ths difference from one side to the other, which isn't bad. I was really hoping this wasn't going to warp with me as I did all this work on it, and kept in the variance to a minimum. Yeah, I was real happy with that. And so now I've got my blank, and next time we do a video, we'll actually start making shoes out of this. You can see kind of how that's going to work. Thanks for being with us, and please subscribe.